So in this case, we are going to consider the part two of what we had working on our literal equations. That is the change of subject of what? Of formula. We had the introduction, actually worked with some of the questions, and from what we had, it seems like some of us had some challenges along. All right, we had some challenges. This one is saying, I'm so cooked. All right. It is so hard, me running away from what? From it. So we want to see, uh, for those who had some challenges, that how can we actually play around with literal equations. What I will give as an advice is that you must actually have the basics. You must understand the basics of equations. All right? Basics of your equations from your grade 9. From there, those basics that you had. The basics you were working with linear equations, where you are also having brackets, where you are also having fractions, different types of questions, solving for x, solving for any unknown that you're given there. 2x plus 3 is equal to 5. You are used to that. If you are used to this, then it will be easier for you to solve these literal equations. Basically, we cannot have a procedure of how to solve, but for the basics, this is what I want you to take into consideration. There are many different formula, and it is not possible to give general rules for changing their subject. It is not possible to give general rules to say, okay, do this in order for you to solve. But we can just play around with the types of questions that we are used to. Then we can, okay, if I'm given this condition, I can work it this way. This is what we have here. However, the following points should be remembered. All right? Whenever we are working with our literal equations, let us put this into consideration. Number one, begin by clearing fractions. If they are fractions, you must clear fractions. Brackets, if they are brackets. And root signs, if we have got what? Root signs, we must consider that. And I'm going to put this one into explanation, how to clear the root signs. You have got a square root. How do you get rid of the square root? Remember, there's a 2 inside that is invisible. So you raise to the exponent of 2. Opposite of what is inside the root is the one that you use as your exponent. So meaning to say, if it is the cube root of something, to get rid of that cube root, the exponent is going to be 3. What is inside there is 3. So you raise to the exponent of 3. So if you are given, let's say, the square root of something, then you raise it to the exponent of 2, you are going to get that something that is under the square root. That is what you're going to have. The same thing, the cube root of something, when raised to the exponent of 3, it is going to give us that something. So this is the case. So meaning to say, if it is the square root of x raised to the exponent of 2, I'm going to get x. The cube root of x Raised to the exponent of 3, I'm going to get x. So the cube root with the cube neutralizes to get what is under the cube root, which is under the root sign. This is the idea that you are going to have. But this is to be considered at the final stage when you've got a single term. Remember from your, all right, this one, it is not from your previous grade, but it is something that actually you're going to have in the next grade. So that is impossible for us to actually apply it. There are some equations which we refer to as equations under seds. Remember, you've got exponents. So you consider equations under exponents, exponential equations, all right? As you deal with your exponents, you consider what? Exponential equations. So it is the same with the seds. You consider those equations where a square root maybe of x, let's say it is equal to 2. So you want to get rid of that square root. You simply raise to the exponent of 2, raise to the exponent of 2. So it is only when you have got a single term, when I say a single term for something that is under the root sign, a single term, it is that part that is the square root, it is the cube root, whatever that you have there. So it must be a single term to something, whatever that you have there on the right-hand side. It can be an expression, whatever that you have. We do not mind about that. All right. Square root of x plus 2, it is equal to 3. This x plus 2, the whole of it is under the square root. So we call it a single term. The square root of it's a single term. So when it is like this, a single term to another part, whether here it is going to be an expression 3 minus x, we do not mind. We simply square it, then we square everything that we see as it is, we square it. That is, you have removed the square root by doing this. So you are left with what is under the square root, which is what? Which is x plus 2, equal to whatever that we have. All right, so I'm not solving here. I'm just showing you the idea of that square root concept wherever you've got a root. So you clear those whenever you have fractions. All right, we're gonna look into some questions and see how to actually apply this. Number 2, you must rearrange the formula so that all the terms which contain the new subject. The new subject is the letter that you're given to make the subject of the formula. Make the letter in the bracket the subject of the formula. The one that you are being given to make the subject of the formula. Let's say there are more terms which contain x. You want to make x the subject. This is what they're trying to say. There is 2x, then it is equal to here. We also have 3xa plus b, something like that. We want to make x the subject. There is x here, there is x here. So you must rearrange the formula so that all of them, all the terms which contain the new subject are on one side of the equal sign. You must take those terms with x, whatever that you want to make the subject, to one side of the what? The equal sign, one side of the equation. So simply, I can take this 3ax to the other side because there is also x if I want to make x the subject. So the moment it crosses the equal sign, remember the concept, it changes the sign. So it'll be 2x. The moment I take the 3xa this side, it will be minus 3xa, which is equal to, you are left with a positive b. So you can just write b as it is. So this is what they're trying to say. You take the terms to one side of the equal sign, the ones that you have the new subject, the letter that is to be the subject of the formula. and the rest on the other, meaning to say the other terms which do not contain the new subject. The terms, maybe you're talking about x, the terms which do not have x, you have them on one side of the equal side. These ones, they have got what? They have got x. Here we do not have x. This is what we must have. So they must be on one side, the other ones on the other side. Do not try to place the subject on the left-hand side if it comes more naturally on the right. Okay. This is what we have here. Most of us, actually, as most of you guys, learners, students, wherever you are, you tend to think that solving for x, solving for any variable, I must have that x on the left-hand side. 2x is equal to 3. You're very comfortable seeing it this way, where you just divide by 2, so x is equal to 3 over 2. When it is 3 is equal to 2x, still there's no change between between these two. There's no effect. This is just one and the same. So simply divide by 2, it means x is equal to 3 over 2. So this is what they're trying to say. If you've got those terms of x on the right-hand side, work with them on the right-hand side. Do not worry about taking them to the left-hand side. In actual sense, do not try to place, just work as it is. You have got maybe something like this, all right? Let us just consider minus bx, all right? I'm not solving anything. I just want you to see what exactly it is happening here. If you see on this question that we have, let's say we want to make x the subject. You are going to take this to the left-hand side. It gets a negative sign, which means you're going to have something like minus bx minus ax, minus, minus. But look, if you would have taken this to the right-hand side, it was going to be what? Positive. So you could have just worked it on the right-hand side because it will be positive. It will be ax plus bx the moment you take that to the right-hand side. And you see, it's very easier to work with positive than negative. Not to say this is wrong. You can work with it. This is also correct. You can work with it. It's not a problem. So do not try to complicate when it is easier. Just work out as it is on the right-hand side. But if you feel comfortable with the left-hand side, then do it. It means this statement, it won't affect you. Just leave it as it is. But if you just apply to the right-hand side as it is. Number 3, if more than one term contains the subject, if it's a condition that can happen, this can happen if, like what we had here, more than one term, this has got x, this has got also x. We are talking about what? X being the subject. This term contains x, this term contains x. This is what they are trying to say. So if that condition occurs that more than one term contains the subject, take it outside a bracket. What are you taking outside? The letter to be the subject of the formula now. You must take it out. That is simply factorize. To take outside a bracket is what? To factorize. So you factor out the term to be the subject. So you simply factor out the letter or the variable there, the letter to be the what? To be the subject. Just like that. So you must factor it out. Take it out. X is to be the subject of the formula on this question here. So x on this term, x also on this term, more than one term. So I can factor x out. I get that x out. So I must be having x out of the bracket. So what am I going to have if I factor out x here? I'm going to remain with a 2. So this is going to be 2. If I take out x here, I'm going to remain with what? Minus 3a. So I'm going to remain, all right, sorry, this was 2. This is going to be minus what? Minus 3a, which is equal to what? Which is equal to b. So you take out that letter to be the subject of the formula. All right, then after, you must divide both sides by the bracket, then simplify as far as possible. As I can see, x here is to be the subject, and there is a bracket. A bracket is a multiplication. So multiplication is opposed by what? Division. Multiplication, division. 2x is equal to 3. How do you solve for x? It's a multiplication. You oppose by what? Division. You divide by 2. X is equal to 3 over 2. It is the same thing. You want to calculate x. So the bracket here representing 2 minus 3a, it is the same as this 2 that we see that is multiplying x. You divide by what is multiplying x. What is multiplying x here is what? Is the bracket. So you're going to divide by that bracket. 2 minus 3a, divide also here 2 minus what? Minus 3a. So this is going to cancel. You remain with what? With x. This is what we want. X is equal to what? 3 over 2. But here it is found in terms of other letters, in terms of B, A, and what? And A. In terms of B and A. You are not finding a numerical value to say X is 3 over 2. No. You can only determine the numerical value when given to say let B be equal to 5, A be equal to 1. Maybe you're given that. You can substitute those values. But for solving for x or for making x the subject in terms of the given letters or in terms of the other letters that are given, this is what you need. This is what you simply need. So we said here, guys, we're saying there won't be a proper way. That's not possible. A proper way or rules for you to follow. But as long as you are to work with this, just try to remember just just these considerations that I've been explaining. Clearing of fractions, rearranging. If more than one term is considered, factorize, then you must divide by what? By the bracket. You won't go wrong. All right. So let us consider some of the questions as we have got this part. All right. So for those who had some challenges, let us hope after this one you'll be able to understand what you're working with and try to work out as many questions as possible. Make A the subject of the formula on this question. Make A the subject. Make A the subject. It is simply solve for A. You are solving for A. So I want you to put this way. Each letter, let it represent a certain number. V, let it be 3. U, let it be 2. And our T, let it be 5, like that. So it's going to be 5A. Let's say you were given an equation like this. Solve for A. How are you going to solve it? All right. You were going to say, all right, the A is already positive on the right-hand side. Let me leave it as it is. Instead of taking this, it will be minus 5A. You are going to take the 2 there to the left-hand side. Why? Because on that 2, we do not have A. We do not have the letter to be solved for. It's a constant. It's a constant. So you take it to the other constant, which is 3. So it will be 3 minus 2. The moment it crosses the equal sign, remember it changes the sign. So it will be 3 minus 2 is equal to what? Since 5a is positive, you're just going to write it as what? As 5a. This is how you're solving. Remember back those basics. I'm talking about basics of your equations that you had before. So this was going to be 5a. All right. Now that you have these letters, don't be confused now to say, okay, there is a V. No, 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 guys. It is the same, like there is a 3, there is a 2, there is a 5, just like what we had here. How are you going to solve? You're going to take the 2 to the other side because we do not have A on 2. So it is the same thing on our question that we are given here. The first thing that we are going to do is to get rid of what? Of U, because U that we have here does not contain, we do not have A. If it was A, maybe we leave it. But we said if the fractions, they are not there, brackets are not there, the roots are not there. So we must rearrange the formula. Rearranging the formula is that all terms which contain the new subject are on one side of the equal sign and the rest on the other. This is the statement that we want. Rearranging. So this is what we want. Where do we have A? A is here. Where do we have A? A. This is where we have A. So we must rearrange to say the terms that contain A to one side of the equal sign. So are we going to take it this side? If you want, you can do it. But taking it this side makes it to be a negative. Take it not, it's a positive. The moment I take it this side, it becomes what? A negative. Why not avoid that? Just leave it as it is to the what? To the right-hand side. Then take the U, which is not an effect, whether it becomes a positive, whether a negative, we do not mind about that one. It is not about U. It is about A. So you take note about the letter to be the subject. Your eyes must be on that letter. The rest, just take to the other side if it is possible. Like this one, we can take it to the other side, just like a 2 to the other side. So you treat U just like a 2 as a constant. So V and U, you treat them as constants. For now, you treat them as constant, just like a number. Just like 3, just like 2. So it was going to be what? V minus U, because it was a positive. V minus U. 3 minus 2. It was a positive. The moment it crosses the equal sign, it changes. Even the letters also, they follow the same thing. So this must be equal to what? 80, where we have a positive. So that's positive 80. Just ignore that. It's a positive. V minus U. Can it be simplified? No. But on the numbers now, here, you are going to simplify 3 minus 2 is what? It's 1, which is equal to 5a. 3 minus this one here, this one represents 3 minus 2. So it is the same as the v minus u, which cannot be simplified on our case. But let us see what is going to happen. You want to solve for a. This is 5a. 5 times opposite of a multiplication is what? Division. So how do I get rid of the 5 which is affecting our a here? We must divide by it, the opposite. Multiplication, you divide. So it was going to cancel. Meaning to say you are left with a. You have solved for a. You are saying your a is equal to what? Remember, you subtracted 3 minus 2 and got a 1. So it's 1 over what? 1 over 5. Remember where we got this 1? From 3 minus 2. In actual sense, it was supposed to be like this. 3 minus 2 is equal to 5a. Then I divide by 5 here. I divide by 5. So it's going to be like this. A is equal to 3 minus 2 over 5. But we can simplify 3 minus 2. This is what is happening now here. V minus U cannot be simplified. But it is the same as the 3 minus 2. What you want is to make A the subject. A, what is affecting your A this time? It is a product. So you ask yourself, how do I get rid of this T, which is affecting the A? Just like the 5, which was affecting our A, we had to divide by it. It is a single term now, so divide. So we divide by T. What we want to remove is T, the one that is on the product. So divide by T. Here, it's everything. 3 minus 2, which represents this one. It is a combined part now. So you divide everything is affected by the T. So you treat it as a single term. Yes, it's an expression, but you treat it. You take it to be a single term. Just divide by what? By T, everything. So you see that T and T was going to cancel on the right hand side. You are left with what? You are left with A. Just like what we had. Once you divide, you're left with A, which is equal to 1 over 5. But here, we cannot evaluate this. We'll just rewrite as it is V minus U over what? Over T. You have made A the subject. You have solved for A. This is to solve for A. Only that when you are solving here, it is found in terms of the other letters. So that is what you have. So therefore, our A is equal to what? V minus U over T. As it is here, you write as it is. As it is. So for those now who would have taken the AT to the left-hand side, we want to make A the subject, remember. There are some who could have taken this AT to the other side because you are used to just, whatever that you are solving must be on the left-hand side. On the left-hand side. So the moment you take the AT to the what? To the other side of, or it becomes a negative. It was a positive here. This one. It was a positive. So the moment I take it to the other side, it crosses the equal sign. It is now a negative. So it will be minus AT. Take note. Minus AT is equal to what? Remember, we're rearranging. So the V must be taken to the other side. So it will be equal to, you take the V to the other side, U minus V. You see now what you have. Which is not a problem if you're used to that. What you want is to make A the subject. What is affecting our A here? It is what? Minus T. This is a product. This is a product. It's just like minus 2A is equal to 5. You divide by what? Minus 2 minus 2. So it is the same thing. Minus A, you want to make it A the subject, positive A. So you must get rid by what? Dividing by negative T. Negative T, it's part of a product. Negative T, negative T. So this was going to cancel. This was going to cancel. So you are left with what? You are left with A. A is equal to U minus V over what? Over minus T. So this is what you have, which is the same as what you have. Only the presentation is different because of how you solve, but they are referred to as the same answers. You can even take the negative up. So therefore, A is equal to minus. You affect the U minus V. So it's U minus V over what? Over T. The negative is on its own. The negative here. It's negative on its own. It is affecting the whole fraction. This is what you have. The negative is affecting the whole fraction. It is not on what? On U. The moment it affects, it will be minus U like this over T. The moment you affect the negative. So you can put the negative here and have your fraction. The answer here and this one, they look different, but they represent the same thing. They represent the same thing. So both will be referred correct. Both are correct. So you see the complications of having A to the left-hand side where sometimes you can just have it on the right-hand side. You see here it was just easier. But if you're used to this, then do it. Still, your answers are referred correct. So this is what this is how you solve your equations. There are different types, like I said before. So you must consider with the question that you're given. On this one, they want us to make S the subject of the formula. Then for those who are having challenges, maybe after this class you still have challenges, the comment section is there. Let us communicate and also join membership so that you can bring your own questions that you do not understand, all right? Yeah, exactly. Maybe you've got an activity from class. Join membership so that we can assist each other on membership. All right. Make S the subject of the formula here. S is one that we want. Where we are given V squared is equal to U squared plus 2AS. All right. The letter to be the subject is letter S. We must rearrange because we do not have fractions, we do not have brackets, this and that. So we must focus on number 2, rearranging the formula so that all terms which contain the new subject are on one side of the equals sign and the rest on the other. So we must make the term which contains S on one side of the equation. So are we going to take this? It is having a positive, guys. Taking this side makes it be a negative. Just leave it. On the right hand, just leave it. It's fine. It's already a positive. So there is 2AS. It's a single term that we have there. All terms which contains S must be on one side. Is there any other term? No. So it's either we are going to take this term to this side, then we take V squared to this side. It is your choice. Or just leave it as it is there because it's already positive, guys. So simply take what? The U squared to the other side of the equation. Because we do not have S here, we do not have S here. So take them to one side of the equation. So it's going to be V squared minus U squared. The moment you crosses the equal sign, change the sign. Positive becomes a negative. So this is equal to what? To 2AS. It's a positive, so just write 2AS as it is. So this was rearranging, taking the terms with the subject, the letter to be the subject, the new subject, which is S, on one side. So this is what we have. 2AS means what? 2 times A times S. It's a product, this one. So how do I get rid of the 2, the A there? I simply divide. Opposite, divide. It is different from, let's say it was A plus S. A plus. You must get rid of the A, take it to the other side. Just like the V square, it was being added. So you can simply subtract it. But for a product, this does not work. You do not throw this to the other side. When it is under a product, you divide. So product, divide. We want to make S the subject, remember. So 2A is affecting as a multiplication. So the opposite of that, to get rid of this 2A, we must divide by it. It is under a product, opposite, divide. But remember, it's an equation. Whatever that you do on the right-hand side must be done also on the left-hand side. Divide everything that you have on the left-hand side by what? By 2A. Just like that. So this cancels. This cancels. You are left with S. So simply, our S is equal to what? V squared minus U squared over what? Over 2A. This is our S, just like that. You have made the letter to be the subject as it is, the letter S. So therefore, S is equal to, just rewrite as it is, V squared minus U squared over what? Over 2A. This is what represents our S. Focus on the letter to be the subject. This is the letter that you focus on. The rest, ignore. Do not say this is a difference of two squares. Let me factorize. As long it is the subject, guys, you are done. All right, let's look into these ones. These ones we are given here to solve for x in the following equations. So there are so many. The first one is the one that we are given here. Ax plus b is equal to c. Ax plus b is equal to c. Make x the subject of the formula. Solve for x. It is to make x the subject. Because as we can see, it is given in terms of what other letters. It is given in terms of other letters. So it is to make x what? The subject. How can we do that? All right. We do not have fractions, brackets, this and that. So we move on to stage 2, rearranging to make x the subject. I mean, to make the term the subject with the subject on one side of the equal sign, which is our term here that has got x is ax. Here we do not have x. Here we do not have x. So the term to be the subject, the term that contains, the letter to be the subject on one side of the equal sign. So you remain with ax. It's already a positive. Don't take it to the other side, guys. It's already a positive. B is the one that we must get rid of to the other side. It's a positive. The moment it crosses there, it changes the equal sign. Or simply subtract B, subtract B. Just like that. Or you throw it to the other side of the equal sign. So it's going to be equal to C. B was a positive. The moment it crosses that equal sign, it changes. So it's now a negative. So this is what we have. It's now minus B. So ax is equal to this. And we are to solve for x. This term, it's a single term. It contains x. It is on one side of the equal sign. And there's another part here, another expression, which we do not have x there. So we are fine. How can we make x the subject now at this stage? Ax, a times a product, opposite is what? Division. So you get rid of a by what? Dividing by it. Both sides of your equation. So this cancels. You are left with what? You are left with x. Product division. So therefore x is equal to what? C minus b, everything over what? Over a. You have made x the subject. You have solved for x. It was an advantage on the left-hand side as it is because it's already positive. Leave it as it is. So like I said, all these questions that we are going to have for now will be solve for x. All right. Another one, solve for x. Given 3ax, all right, is equal to bx. This is what we are given here. 3ax is equal to 2bx plus c. All right. I want to get rid of this one. So this is what we have. Let's see what we have here. 3ax is equal to 2bx plus c. Remember, rearranging, since we do not have fractions, so we just have to rearrange the formula so that all terms which contain the new subject are on one side of the equal sign. The letter to be the subject, the one that you are solving for, is x. So do we have the terms with x? There is a term here with x. There is also a term here with x. This condition, you must be very careful. We have got two terms with x. So we must rearrange and we must take one to the other side. It's either we're going to take this to the other side, to the right side, or we take this to the left. Which one is easier? Guys, as you can see, they're positive, all of them. So the moment I take this one to the other side, it's easier because it's already a positive term that I'm having there, and it's a single term. This one is a single term, as it is. So take 2bx to the left-hand side. So meaning to say, we're going to have 3ax. The moment we take this to the left-hand side, it changes the sign. It's now a negative. It was a positive. So it'll be minus 2bx, or subtract it. All right, so this is equal to what? To c. This term does not contain x. It is on its own. We do not have x there. So we leave it on the other side as it is. So that's a positive c. So this is rearranging the formula. This is rearranging it. So after rearranging, in our case, we have this condition that if it's a condition that can happen, and this is what we have there. If more than one term contains the subject, this is what we have here. More than one term, we are talking about x. This term contains x. This term also contains x. So what do? We take x out of the bracket. We factor out. We factorize. The first stage was rearranging. This is what was just rearranging. Now we must factorize. We factor out the x because it's common between the two terms. So the moment I factor that x, I'm remaining what? If you take out x, you remain with 3a. All right. If you take out x here, you remain with what? Minus 2b. So that's it. This is equal to c. X times this bracket. X is, remember, I want to make x the subject. So the moment you take it out, it is now a single. It is on its own. So we can say, okay, what is affecting x and how can we remove it? It's this bracket. This bracket is under a product, just like 2x is equal to 3. Under a product, divide by what? By 2. So also divide by what? The bracket. Divide both sides by the bracket. This is what we have. So the bracket, 3a minus 2b, as it is here, as it is 3a minus 2b. So this cancels. A bracket of 3a minus 2b, 3a minus 2b cancels. You are left with what? You are left with x, the letter to be the subject, the one that you are asked to solve for x. So therefore, x is equal to what? What you have on the right-hand side. C over what? 3a minus 2b, just like that. So it's all about revision, guys. Revise. So here we're to factor out, factorize. Then we divide by the bracket. Factorize. Take it outside of the bracket. Factor out the letter to be the subject. Then divide by the bracket. Simplify as far as possible. Just like that. All right. So you see, guys, it's just a matter of revision. Solve for x. We are solving for x. Just a matter of revision now. More revision, that's more questions. All right, let's consider another typical question. Again, solve for x. On this one, we have x. We also have x here. Two terms, actually. Two terms. Already on one side. So rearranging here is already there. Rearranging. They're already on one side. But there are two terms now which contains x. There are two terms. This one is a term which has got x. This one is a term also which has got x. So what do? We factor it out. So if we were to factor x here, guys, this is x squared, this is x. X squared and x. So we must factor out the highest common factor, remember, which will be what? X, the one that is called the smallest power. All right, no problem. Let's say we factor out x. See what was going to happen? You're going to have a bracket. X times All right, ax squared divided by x is going to give us what? It's going to give us x. There are two of them, so divide by 1 is going to remain with x. So that's ax plus bx divided by x. If you take out this x here, you're going to remain with what? Positive b. So this is what you're going to have, and that is equal to what? To 0. So are we going to say, since we have got a bracket, we equate to 0? I mean, we divide by the bracket like what we saw here. All right. The division of the bracket here, it was because when we factored x, we remained with something inside the bracket which do not contain x. We do not have x in what is inside the bracket. And it is equal to a certain term. In this case, guys, it is a different situation. This here contains x. What is inside the bracket contains x. So we cannot divide by the bracket. And also, there is a 0 there on the right-hand side. So what can we do? Remember from our equations, the 0 product. All right? If a times b is equal to b, is equal to 0 like this, a times b is equal to 0, it simply means a must be equal to what? A must be equal to 0. Or our b must be equal to 0. This is the condition of the 0 product. Do you remember this? All right. So let's apply it. You see where we are? Because it's part of equations. Don't just focus on to say it's change of subject. Yes, it's change of subject, but under equations. So the 0 product also plays a role when it is what? Applicable. So meaning to say from this concept alone, x must be equal to 0. It's a product of these two terms, a times b. So x must be equal to 0, or the bracket represented by ax plus b must also be equal to 0. A is equal to 0 or b. What is under the product? It's x and the bracket. So from the first one, we have already solved for x. It means x is equal to 0. Remember, our question is to solve for x. All these are to solve for x. So the first one, we already have a solution here. X is equal to 0. Can we do anything? No. We cannot say 0 is equal to b or 0 is equal to a in terms of any other letter. No, that is what we have there. What about the other one? Because it is also containing x. This one, it contains x. So it means we must solve for x there. So we are back now to number 2. Rearrange the formula so that all the terms which contain the new subject are on one side of the equal sign. Because there are other terms, b. It's another term where we do not have x. So we must let the term with x on one side of the equal sign. So let us rearrange. Ax, that is the only term which contains x. So it is equal to what? We are forced to take the b to the other side of the equation since we do not have x here. So the moment it crosses, it changes the equal sign. So it was going to be 0 minus b. It was a positive, so it's going to be a negative. 0 minus b is what? Minus b. Remember, 0 minus 1, 0 minus 2 is that number with a negative. So that b with what? A negative. So this is equal to what? Negative b. The moment you take it to the other side. So that's minus b. Remember, you want to make x the subject. You want to solve for x. We are back to the product here. A times x is equal to b. How do I get rid of the a under a product? Opposite is what? Division. So we must divide by a, divide by a. So this cancels. You are left with what? you are left with x. So therefore, x is equal to what? Minus b over a. We have another solution for that x. So in our case, there are two possible solutions representing x. The one that is equal to 0, or the one that is equal to minus b over what? Over a. Just like that. There are two possible. So you see how it turns out to be. Under change of subject, you are now from a normal equation. Apply that zero concept where it is applicable. Solve for x. All right, let's look into another one. There are so many so that we can finish up. On this one, we have got, okay, solve for x again. But what is that we have? A 0. Okay, no problem. But as we can see, that's a difference of 2 squares here. Remember, 4 is what? 2. 2 squared. So it's 2 squared x squared minus y squared. Remember, a squared minus b squared is equal to what? A minus b into a plus b. So we can use the difference of 2 squares. 4 as 2, x squared as x squared, y, and so on. So what is the square root of 4? Just need the square root of this part. That's 2x. So that's going to be 2x minus the square root of y squared, which is y. So 1 is going to subtract. Another bracket is going to what? Is going to add 2x plus what? Plus y is equal to 0. A minus b, a plus b. One subtracts, another one adds, or the order does not matter. But what are we noticing right now? We are back to the zero product. The product of these two to be equal to 0, it means either one must be equal to 0. 2x minus y is supposed to be equal to 0. Or the 2x plus y must be equal to 0. You have two conditions to be worked on where we are to solve for x. So we go back, we rearrange just like the previous case, making the terms to be a subject on one side with a subject. So 2x from the first one, that is the only term which contains x. Here, there is the only term also which contains x. So just have to remain on the left-hand side. So 2x will be equal to what? I take the minus y to the other side because we do not have x here. The moment it jumps, changes the sign, it's now a positive, minus positive now. So 0 plus y is equal to what? That's a y there. So 2x is equal to y. The same thing on the other equation here. 2x remain on the left-hand side. That's the only term which contains x. So we must take the y to the other side. It will be a negative 0 minus y, which is what? Minus y. So that is equal to minus y. Remember, we talked about this. So from this one, 2x is equal to y. This one, 2x is equal to minus y. So what does it mean? Simply solve. Divide by what? Divide by 2. A product opposite is what? Division. So it's the same thing here. So this was going to cancel and you're left with what? With x. So meaning to say x is equal to y over 2. Or on this side, if we are to divide, it means x will be equal to what? Minus y over 2. Just like that. So these are the possible solutions of x. In terms of y, x is the subject of the formula. Just like that. They will ask questions like that. Solve for x. You are solving it in terms of other letters, in terms of other variables. Change of subject of formula. Apply the principles where it is what? Applicable. Another one here, it is x squared minus 5xy plus 6y squared is equal to 0. Again, we are to solve for x. If we take a closer look, it is a quadratic from this trinomial that we have. We've got a quadratic x squared. All right. Let's say you were to, I want you to consider this. Let's say you were to factorize x squared minus 5x like this plus 6, because 6 is a constant. How are you going to factorize? You're simply going to say, all right, this is x, this is x. The factors of what? Of 6, which adds up to negative 5. Factors of 6, you can think of what? 3 and 2. But to give us a negative 5, when we add, we must have negative 3 and negative 2. So you're going to put negative 3 here, you put negative 2 here, isn't it? This is exactly how you're going to factorize. Guys, there's no difference on our question. What we simply have added is the y here on x, the y here on the end. It is our constant part to affect the constants. So y there affects the constants when that condition happened. You just factorize as usual, then you put y on the constants. That's how you factorize this. So meaning to say here, having this factorized, it was going to be x minus 3y, x minus 2y, just like that. You factorize where the constants, I mean, the way that it was uh, without this y here. Then you just put y on your constants, on 3 and what? 2. So that's it. Are you seeing that you are back to the zero product? We want to solve for x. This bracket, there's another bracket equal to 0. So either x minus 3y is equal to what? To 0. Just like that. Or x minus 2y is equal to 0. So there are two of them. Meaning to say two possible solutions. Solving for x, I'm just going to take the minus 3y to the other side. Here, I'm just going to take the minus 2y to the other side. Already, I'm having x. So I'm going to remain with x, rearranging. So x is equal to what? Minus 3y to the other side, that will be a positive. 0 plus that it still remains as a positive. Or x is equal to minus 2y to the other side also becomes a what? A positive. So these are the two possible solutions for x. In actual sense, we have made x the subject of the formula. This is what we have. So guys, you'll be having this. Revise. All right, looking into this one, it is still one and the same. We had a similar question to this one. All right, still solving for x. We can choose to work it to the right side since it's positive on the right side. We can take it on the left-hand side. It is up to you on that one, right? So it is actually up to you the way that you feel like it is easier for you to have your x. All right. So if I want to maintain the positive, it means I was going to take this to the right-hand side, which means it's going to be negative. 0 is equal to 8x squared minus 18y squared. Remember, if a is equal to b, it simply means b is equal to a. So if this 0 is equal to this, it means this also is equal to 0. I can just write as it is 8x squared minus 18y squared, as it is being equal to what? To 0. I haven't changed anything here. I haven't changed anything. Just rewriting. Is it a difference of 2 squares? You do not say it's a difference of 2 squares because you just saw x squared, y squared. What about 8 and 18? Are they perfect squares? No, these ones are not. Square root of 8 is not an exact value, cannot be simplified, like to give us an exact value. which is what? A whole number. So it means you must consider to factorize first. To factorize. What is common? 2 is common. Is the highest common factor between 8, 2 to the exponent of 3. 18 is going to be 2, 9, 3, 3, 3. So it's 18 is what? 2 times 3 squared. So you can see that the highest common factor is what? Is 2. So you can factor out 2. And that's remaining with 4x squared minus 9y squared if you divide by what? By 2. And that's equal to 0. You see that what is remaining here is a difference of 2 squares. And also the 2 that you factored out does not matter. You can divide by that 2. It's a constant. So you're just left with what? 4x squared minus 9y squared is equal to 0. The 2 is a constant. It's a constant, so get rid of it when it is possible. So we can apply the difference of 2 squares because these are now perfect squares, 4 and 9. We can determine their square roots. The square root of 4, which is 2, x squared, that's x. 1 subtracts the square root of 9, that's 3, the square root of y squared, which is y. So one is going to subtract, another one is going to add. So that's equal to 0. All right, I'm going to explain another way also that you can use, which is fine. Then from the 0 product, 2x minus 3y is equal to 0, or the bracket of 2x plus 3y is equal to 0. As you can see, guys, it's now a repetition. We want to make x the subject. We want to solve for x. So take the minus 3y there, take the positive 3y there. Thus 2x is equal to positive 3y, or 2x is equal to negative what? Negative 3y. Then divide by 2, just like that. So therefore, x is equal to 3y over 2. Or x is equal to what? If we divide by 2 here, it's going to be minus 3y over 2, just like that. So we have solved for x. But I want us to note something here to say that if we have x squared is equal to 4 and introduce the square root like that, it means x is equal to plus or minus 2, the square root of 4. There are two possible values, plus or minus. This is the same thing, guys, that we could have done on our equation here. Understanding that it is the same thing. You were just supposed to solve it in this manner. 18y squared is equal to 8x squared. I want to make x the subject, or I'm supposed to solve for x. Just divide by 8 because we've got a single term containing x here. So divide by 8 by 8. So it means x squared is equal to what? 18 over 8, that's 9. And this is, so that's 4. And this is what? 9. So it's going to give us 9y squared over what? Over 4. X squared. This is not x. This is x squared. What about x? The square opposite. X squared is equal to 4. You introduced the square root. Same thing here. Introduce what? The square root. So it means x will be equal to the square root of whatever that you have. If it can be determined, then simplify it. Here it's a single term. We can simplify knowing that square root of any number is plus or minus. So meaning to say our x will be equal to plus or minus. We simplify. Do we know the square root of 9? Yes. Square root of 9, that's 3. Square root of y squared. Remember, square root and squared neutralizes. You are left with y. Over what? The square root of 4, which is 2. So this is what you have. X is equal to this, plus or minus this. So you can rewrite to say, therefore, x is equal to what? It can be positive 3y over 2. So that's 3y over 2. Or x can be a negative what? 3y over 2. Just like that. And we can see this exactly what we obtained. So it's up to you guys. You look, this one, it was long away because you want to maintain factorization, a difference of two squares. It's okay if you understand it. But when you have got this consideration, you can also apply it this way. Just, you're done. You're done. We had a similar question like this. I want you to use it. You'll see that it's going to be one and the same. One and the same. So this is what you have, guys. Let me know what you think about your um, change of subject, working with literal equations this time. How do you understand so far? And if there are questions that you have past exam, that's the platform. Let us send those questions so that we can look into them and also join the membership so that you do not miss any of the other classes that we are going to be working on. Also on revisions, question papers. We shall be doing question papers of these topics. So make sure that you are part of the membership so that you do not miss any of the classes that we are going to be offering on that membership platform.